We'll now discuss the law of sines in solving these triangles called SSA, which tells us we know two sides and one angle that's not the angle trapped between them. And this is known as the ambiguous case, essentially because we could have a possibility for no solution, a possibility for one solution, but we could also give rise to two possible triangles that satisfy this. And this is why it's known as the ambiguous case. Let's consider this triangle here. We can't necessarily find one of the angles easily, but we can start. Well, we will actually have to start with one of the angles. So we know that sine of 50 over 1 has to be equal to sine of A over 3. So now we just have to work this out. We'll start with sine of 50 degrees divided by 1. Gives us 0.766 is equal to sine of A over 3. Multiplying by 3 gives approximately 2.298 is equal to sine of A. And if we try to use the inverse sine button on the calculator, you'll see an error. Essentially, this is impossible. There is no triangle with this information. We can't do this inverse sine function for anything greater than 1, because essentially that means that our opposite side is bigger than our hypotenuse, but the hypotenuse has to be the longest if we give a right triangle. So occasionally we do get these errors, and this is the case where we have no solution. Let's look at another one. This time, I have sine of 80 over 4 is equal to sine of B over 2. So we just need to work this out. And if we try to simplify this, do sine 80 divided by 4, go ahead and multiply by the denominator of 2. We'll get 0.492 is equal to sine of B. And then we can use the inverse sine to find angle B. We get that it is approximately 29.5 degrees. And at this point, we need to check to see if there's a second case. Essentially, if I do 180 minus 29.5, in this case, we get 150.5. So there is also the inverse sine of 0.492. It also gives us an angle of 150.5. However, you'll notice that 150.5 plus 80 is already too big for a triangle. This tells us that there is one solution to this triangle because we can only find one possible triangle. The second angle that resulted from this function did not give a valid triangle. And now we can continue solving. We can now find our angle pretty easily. 180 is 80 plus 29.5 plus C. And this tells us that C is 70.5. And so now I just need to find my missing side. We know that sine of 80 over 4 is equal to sine of 70.5 over the side C. Fix that. 70.5. And now if we solve this equation, we can get C. And when we do, we get approximately 3.83. So now I have solved this triangle. Here we have one more triangle. And in this case, we have that sine of 20 over 7 is equal to sine of angle B over 5. And if we go ahead and simplify out the right-hand side and the left-hand side and multiply by the denominator, we get that approximately 2.44 is equal to sine of b. We can then use our formula, or our calculator rather, to find the inverse sine, that sine to the -1, to get angle B, which is 14.14. And once again, we have to do our check. Try that again. We'll do 180 minus 14.14, which gives us 165.6. We can also see that if my angle B was 165.6, that would once again be too big. So once again, we have one triangle. I can now find angle C using 180 minus B minus my other angle to get 145.6. We can then do sine of 20 over 7 is equal to sine of 145.6. 145 point. Sorry, that should be 86. Slight mistake there. That's okay. Over side C. And then we can solve this equation. And we get that side C is 11.49.